Hello everyone, welcome to my channel Coding Together. My name is Vikas Oza. Today we will see another lead code problem, that is course schedule. It's a medium level question. So let's read the problem statement. That there are total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites I equal to AI comma vi indicates that you must take bi first if you want to take course AI. So for example, if the pair is 0, comma 1, this indicates that the course 0 has to be taken first. Sorry, to take the course 0, you have to take the course 1. We have to return true if we can finish all courses, or otherwise false. For example, if we are given two courses and the prerequisite is that we have to complete 0 first to complete 1, we can easily do it. First we'll complete 0, then we can complete 1. Let's see this example. Like it's saying, to complete course number 1, we have to complete course 0, and for to complete course 0, we have to complete course 1. So it's a deadlock. We will not be able to finish the course. It's impossible. So now let's see how we can solve this question. So this is a problem of cycle detection. Cycle detection in directed graph. So we will use DFS algorithm. So to know more about DFS algorithm, I have already um, let video on DFS algorithm on graphs. I will paste the link in the description on this in this video to better understand the DFS algorithm. Let's see. First, we have to create our adjacency list here. Adjacency list here. So adjacency list will be created. This is also, I have shown this in the BFS video, BFS traversal, how to create adjacency list, that I have described thoroughly. So go check out that video to more understand the adjacency list. So we have created our adjacency list. This means that if we want to complete a course, B has to be completed first. So the source will be A and the destination will be B. So this is the graph now, and corresponding adjacency list is this. Similarly, to complete B, C has to be completed. For C, E has to be completed. To complete E, F and D, and D, B has to be completed. And F, for F, there is no course to be completed. So let's see how we can detect a cycle in a graph using all the information we have. We have the adjacency list, and now we will create the visited array. In the DFS approach, we always create a visited array of size v. We represent the vertex. So initially all the vertex are unvisited. So 0 represent unvisited, 1 will represent visited, and 2 will represent processed. What is processed? We know unvisited, visited. What is unprocessed? Unvisited and visited, we are getting some idea, but unprocessed we don't. So let me describe all the three once again. Unvisited, when we visit the node, we have not visited the node, that is unvisited at the initial condition. Visited is whenever we visit the node or vertex. And processed means that during the backtrack it's done, right? Means for this vertex, so let's suppose for this vertex F, when it has no childs, it has no uh, elements in the adjacency list, no neighbors. So it for to complete this course, we have no dependencies. So this course can be completed. So this course can be completed. F can be completed. So it means process means F can be completed. That particular course can be completed or is completed. If it is completed, then we'll mark as 2 as processed. So let's start with the source node A. So whenever we'll visit node, we'll mark it as 1. So we'll mark it as 1. From A, we'll check the adjacency list. We have to go to B. So to complete A, we have to complete B. So we'll visit B. So we'll also mark B as 1. From B, we have to go C. We are checking the adjacency list. So we'll mark C as also 1. Now from C, we have to go to E. So we'll mark E also 1. Now from E, we have two courses to be completed first, that is F and D. So let's go to F first. So if I go to F, so now when I visited it, so I have to mark it as 1. Now from F, there is nothing, no child, no courses to be completed to complete F. So it can be completed. So we can go from F to E. We can go from F to E back. So when we go from F to E, we have to change from 1 to 2, stating that F can be completed. F is completed. So we'll backtrack. So when we backtrack, we'll say false. There is no deadlock. There is no cycle. There is no cycle from F. I am saved. I don't have any cycle from me. Please go back. Means it's okay. So we'll return false with a 2. So it will be 2. Now from E, we will go to D. When we will go to D, so D is also unvisited. So we'll mark D as also visited. So we'll mark D as also visited. Like it will be A, B, C, D, E, F, just to clarify. Now we have marked D as visited. Now from D, we have to go to B. We have to finish B first. So when we go to B, oh no, we check B. On B, we are only visited. It's only visited. That's an important point. Here we are only visited, right? We are only visited here. Now that's not acceptable. That's not acceptable because we had started from B and we again reached B, right? In the same path, in the same loop. So that's not acceptable. It has to be processed. It has to be processed. It has to be marked as 2. So it's 1, it's visited. So then we will return false. So return true. Means no, it's a deadlock. It's a cycle. True will represent that it's a cycle. It's a deadlock. Because B is visited, it's not processed. Because B is not completed. You are asking for B, but B is not 2. We cannot make it 2, right? Because so that's why, because it's in the same journey from A to B, C to E, C to then B, D to B. We were reaching B. So this 1 will tell us that no, it's not processed. So go back, it's a deadlock. If it would have been 2, then yes. So 2 is acceptable value for an auto deadlock. So for in the F, in the case of F, right? F had no dependencies. So clearly F said that yeah, I am processed, I can be processed, I can be completed. So it's a false from me. There is no deadlock from me. So it's a deadlock from B because it's a 1 will return true, will return true, will return true, right? And will return 2 from here and will return true and will return true. So this is how it will return true if there is a deadlock, and if there is no deadlock for any path, then it will be false. Redrawn the diagram, the graph, and this time I have eliminated the edge between B and D, and we have also removed from the adjacency list the connection between D and B. So let's see uh, how it will turn out to be no cyclic or non-cyclic. So first we will again start with the source A. We will visit it, so we'll mark it as 1. From A to B we'll also mark B as 1, because we'll check in the adjacency list. It says that to complete A, go to B, complete B course B. From B we'll see in the adjacency list complete C, so we'll go to C, we'll visit C, we'll mark as visited. From C we have to complete E, so we will go to E, we'll visit E, so we'll mark E as visited. From E there are two courses that needs to be completed, that is F and D. So for F also we'll mark it as visited, and when we backtrack, because there is no more from F, we'll check the adjacency list, there is no courses to be completed first, then we'll return, so we'll mark it as completed or processed, means this course can be completed, or there is no deadlock from F side, so we'll say it's false, there is no deadlock. Or we'll reach E. From E we will visit D, the other course that needs to be completed. So for D we also mark as visited. For D also we'll mark it as visited. Now when we now for D there is no nothing in the adjacency list, means if D is empty. So now D can also be completed, so there is no deadlock from D side, can be processed, completed easily, so we will return false. So for A, B, C, D, D will change it to 2. Now we will go to E. From E, because as both the courses are completed, so E can also be completed, so we'll go backtrack, so we can change it to E2 also 2. So D is also 2, and E can also become changed to 2. Now from C, as these three are completed, so this will be returned false, and from C will return false because all the courses are completed. So now we will change C to 2, and others are already 2. From C we'll go to B, because there is a false from the rest, from the backtracking from the inner recursive calls. So we'll when we visit B again, when we visit B again from the recursive call, we'll change it to 2. So we'll change to B to 2 as well. Rest are 2 already. And from A, and B will return false to A, that there is no deadlock from my side, and A will return false, and we'll mark all the vertices 2. So in this way, if there is no deadlock, it will return false. So the code part of it. Now here, as you can see, we have taken the visited array, we have created our visited array, and we have created our adjacency list. So to know how this is created, this has been explained in the BFS traversal video. I'll paste the link in the description, so you will get how this adjacency list is created. It's nothing but a array of linked list, and we are taking the source and destination information from the prerequisites. So here this part is our source, and this will be our destination from the prerequisite. Rest all is same, exactly the same code as described in the BFS traversal graph video. I'll paste the link. You can check out that video for this traversal link. Now, once we have our adjacency list created, we'll start the similar DFS algorithm. This has been also described in the DFS uh, traversal video. So for more information, you can check that video. So we'll traverse the for each vertex, for each number of courses. Will if that uh, course is not visited, we'll check whether it is a cyclic. It will lead to is cyclic or not. Then, if it is cyclic, then we'll return false. Then why returning false? Because we cannot finish the courses. That is why returning false. If it's is leading to the cycle. If it's not leading to the cycle, then we'll return true. We can finish all the courses. So check. So let's check the is cyclic block. So is cyclic block, we're taking I as a parameter, visited as a array, and adjacency as a list of our adjacency list that we created. Now it's a simple BFS block. We will mark as visited the course on which we have entered. Now for each dependent courses for that particular ith course, we will check whether it's visited or not visited. If it's not visited, then we'll perform the DFS or is cyclic over that dependent course or the child course. And if it returns true, then we'll return true from this uh, block. Otherwise, if it is not equal to 0, then we'll check whether it's 1. If it's 1, we'll return true. Then it's a cycle. And if there is no cycle, if there is no cycle, if the all the childs of the particular course are processed and they are not leading to any cycles, then we'll mark that node as processed and will return false. So you remember we checked for f, right, where there was no dependent childs, right, dependent courses, and we marked it as processed when all the children are completed. So, and again, when there was no edge here, and for E, all the childs were completed, then we also marked it as 2. So that's this part, is it as 2, and then we return false. So every time any course that can be completed that is marked 2 will return false from it. So yeah, this is a simple cycle check that we do using DFS. So let's run the test cases. So all the test cases are passing. So hope you like the video, and for more such videos, please share and subscribe. It will give me motivation to keep preparing these videos and posting these videos, coming up with new Leetcode challenges every day. Thank you.